Okay, so far we have discussed about that one. What we have discussed? So node analysis, mesh analysis, super node and a super mesh we have discussed. Then from that one, this is a fourth one we have discussed. So simple to say, node analysis means Kirchhoff current law plus Ohm's law. So assume the direction in all are the outward directions. So these 2 points you can keep in your mind. That's all. Then next one, mesh analysis. So mesh analysis means what is that one? Kirchhoff voltage law. Okay, Kirchhoff voltage law plus Ohm's law. So in that one there is a 2 point. So how many rooms are there? So based on that one, you will go to clockwise direction or anti-clockwise direction. You will go to assume I1, I2, I3 you can give. Then write the equation, simplify. So that's all about that mesh analysis. Then super node. What is a super node? Between the two nodes, voltage source are present. If it is a present, means from the voltage source you can write the equations. So what do you want to write? Where is a plus sign? This a plus sign is related to, connected to that V2. So V2 minus V1, it is equal to the source value 12. After that one, remove the voltage source, make it as a closed circuit. Whatever you have connected, everything short circuited. Then short circuited. From the equation, as usual, assume outward directions. Okay, Kirchhoff current law plus Ohm's law based, you will go and write the equations. So super node, then super mesh means intersecting the two loop current source are intersected. Okay, in that intersected, what is the my current source direction, downward direction. So who is the follower? I1 is a follower, downward direction. So I1 minus I3, it is equal to 10. That's all. Then after that, I remove this one. Yes, I got connected. How many rooms are there? There is a 2 room, 1 room and 2 rooms. As usual, this one you will go write the equation. Then this one you will go write the equation. So you can keep it. Here is a cot. So this is a room. I said this is a one cot available. Here is another cot available. That's all. So let's we go for that one. Yes, electrical source, practical voltage source, and then practical current source. So voltage source is connected series with resistance, current source is connected parallel with the resistance. These resistance are the equal. If it is a 5 means this is also 5. Okay, then how to find out the I? Ohm's law. I is equal to V by R. So this V value divided by R value. Then you can find out the I value. Suppose they are given for that current source, then find out the voltage source means with the resistance value is a 10, then same 10 you can write. Okay, then current value also 10. Then what is the voltage value? So here is a 10. First here is a 10. If it is 10 means this resistance value is a 10 over. Then current value 10. Then what is the value of the V? V is equal to I into R. I into R. What is I value? 10. And R value 10. 10, 10, 10 multiply 10. What is that value? 100. Then this is the value is a 100. That's all. So this is a voltage transfer. Okay. So largest circuit you will going to transverse. Okay, this type of circuit only one thing you can keep in your mind. Okay, so here is what is there. So A and then here source. See here, this is a always you want to keep in your mind. This is a father. There is two children. Okay, one is here is children available. Another one is children. One children is studying at that second class. Another children are the third class. Who is the father? Father is a common. Father is a common. So that one you can keep in your mind. So whenever the voltage source is coming means this is connected to the 2 as well as connected to the 4. See here I have draw separately. Then after draw that one I have put the circle. So what is this one? This is a practical voltage source. This is a practical voltage source. So this circle is I will going to replace into the current source. Similarly, this circle is replaced into the current source. Only one thing you can keep in mind, where is a plus direction? It's upward direction means up arrow you can give. Suppose plus is in downward direction means, I mean plus with respect to minus means, then give the arrow in downward direction. This is important. Keep in your mind. Okay, fine. Okay, so what I have did, so this circle is replaced into that one current source. This circle I am going to replace into the current source. And after that you have look it. So this is a two resistance are parallel. I will going to replace into the single resistance, and here is coming. Okay, then after that what I have did, so this is I have put the circle to replace into the practical voltage source. So this resistance is coming on the series. So 1 ohm is coming series. 1 plus 1, what is the value? 2. So 2 ohm. See that. So after that what I will going to again I will going to put the circle. Okay. Again I will going to So here is a current source, okay, and then here is a practical voltage source are there, okay. So again I will going to put the circle. So this circle is replaced into that one. What is I have replaced? Current source I have replaced. Yes, I have replaced. The 2 ohm is coming here. This load is the same point. So now you have see very simplest one. Both current sources are in the upward direction. So you will going to add 2 plus 2 by 3 plus 1 by 2. Then answer. Then current 7 by 6. So how many resistance? 1, 2. So this is a load resistance. For example, it means I will going to keep it as it is. Then these two resistance are based parallel. Then replace into the single resistance. Then after that, if you want to, these two resistance are the parallel. Replace into the single resistance. So this is a method for the source reduction technique. Source reduction technique. Actually, what is there? Ask the question. You will going to see that one. Find the voltage across. Find the voltage in that across the 5 ohm. They are asked the question. Vx. So Vx they are asked here. I think they are mentioned about the Vx. Vx. This is a Vx point. So find the Vx. So find the voltage across the 5 ohm. Then you want to find out how to find out. So what is the formula? V is equal to I into R value. I into R value. R value is given. Yes, R value is given. I value you need it. Then I have found the I value 7 by 6. 7 by 6 is a, what is this one? It will going to divided. It is a parallel. Okay. So parallel means what will happen? 7 by 6. Okay, I1 plus I2 it is equal to 7 by 6. I1 plus I2 is equal to 7 by 6. Otherwise, simplest method what you will going to do? This one I will going to replace into the voltage source. I will going to replace into the voltage source. Okay, then followed by the resistance. What is my resistance? 1.2. So 1.2. Then here it is, what is that one? 5 ohm it is there. 5 ohm and connected across this point. What is the V value? V is equal to I into R. What is I value? 7 by 6 multiply 1.2. So this is my V value. Okay, this is my V value. Then can you find out what is I value here? Find the I value. What is the flow of the current in the circuits? You will going to find out alternatively. Then I is equal to, what is the formula? I is equal to V by R. V by R. Okay, what is the V value? This is a V value. 7 by 6 multiply 1.2 divide by these two resistance. What is the resistance? Okay, open the bracket. 1.2 plus 5. Then find out the current value. This is the I value. So I value is a flow of the current. Okay, so this is another method. Similarly, here is a current source is connected across this point. So what is that one? You have splitted here across and then split it across. Then after that, this dotted is replaced into the voltage source, and further you will going to reduce. And this one is replaced into the voltage source, and further you will going to reduce. So step by step you will going to reduce. Then these resistance are connected in series. I will going to replace into the one resistance. Here what is their resistance and voltage source are there. So this is we will going to put the circle to replace into the current source. Similarly, this is I will going to replace into the current source. Then this total part is I have reduced into the one current source. Then after that, this part I will going to keep it as it is. I will going to change into the voltage source. Okay, these two voltages are the same plus directions. Then add three resistance are there. Then you will going to add the three resistance. So this is step by step you will going to do the process. Okay, so let's we go for that. Okay, next one, duality. So already you are very well know about that one. So duality means what is that? What is that one? Just opposite. All of you stand up means all should sit down. Sit down. So all members should stand up. Just you can do that opposite. So here voltage source means current source. Current source means voltage source. Resistance means conductance. Inductance means capacitance. So just you want to change. Okay, then how to execute it? So here is a room. Here is a room, so this is a room number A, only one rooms are there, room number A. Then I'm standing in outside, this is a room number A. How to go from room number A from outside to inside? Then you need to take the three column in your tabulations. Column number 1, column number 2, column number 3. What is the column number 1? This is a path 1, path 1. This is called elements, this is called duality. So how do you go from, okay, outside to inside? So n to A place, so through the V I will go. So n to A, write it, n to A, n to A I will go through voltage. Then n to A I will go through inductance. N to A I will go through inductance. Then n to A I will go through the resistance. N to A I will go through the resistance. Then after completed these two tabulations, then do the duality. V means I, this is inductance means capacitance, resistance means conductance. Then so you will going to write, now draw the circuits. This is a point is A, this is a point is a N. Then n to A I, here is n, from, see here, n to A I, where I am starting n, so arrow is going on upward direction, n to A I over. So when you will going to draw, take the column number 1 and 3. So n to A I, n to A is through C, n to A, this is n, this is A, here is a capacitance. Okay, then n to A conductance, here is n, here is A conductance over. So these are conversions. So let's we see one more circuit. See here, how many rooms are there? There is a two room, room number A, room number B. So as usual, I'm standing in outside. How to go from that outside to room number A? One way, second way, that's all. Similarly, outside to room number B, I'm going. So how, is there any possibilities room number A to B? Yes, it's a possibilities there. Through that one, I will go. It's a very simple, you will want to proceed. Okay, let's say you can come to the graph. In the graph, what you want to do? So before you are going to proceed, you want to keep in your mind, so these four things is a one. What is this one? Either R, L, C, all are under voltage source, all are the closed line, all are the closed lines. If it is a current source, means don't consider, it is a open circuit. Okay, this is a graph, see circuits. So closed line, connected, 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 because no current source. So this is a graph drawing. Where is that one? See here, I will going to draw it. Closed, 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 closed. So here, what is this one's voltage source? Plus minus. Then closed, 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 closed. Okay, only node point. So don't consider here node point. You will, how many nodes? 1, 2, 3, 4 nodes. That's all. So this is a graph. This is a graph. That is a matrix. So in the graph, there is a three matrix: incident matrix, tie set matrix, cut set matrix. So keep in your mind, okay, matrix you want to draw. So in the x-axis is a branch. Branch is a common. All x-axis are the branch. All the x-axis are the branch is a common. Okay, that's all. Okay, and then next one, in that instant matrix means y-axis. Here is a node. Here is, what is that one? Node. How many nodes are there in your circuits? 1, 2, 3, 4 node. Then you can give the A, B, C, D. Then you can write. So node versus the branch, that is called the incident matrix. Node versus the branch is called the incident matrix. Node versus the branch is called the incident matrix. Okay, next one, tie set matrix. So branch is there already. Okay, branch versus the tie. So branch versus the tie, it is called a tie set matrix. Similarly, cut set matrix, cut versus the branch, cut. So here is a cut versus the branch. So x-axis is a branch, I already said, no changes. So here is a tie, here is a cut versus the same. Okay, then, so keep in your mind, what I want to keep in my mind. So Ty said only one hero in the film is only one hero. Okay, what is the hero? See that one, the dotted line is a hero. Dotted line is a hero. Okay, in the loop only one hero. On the loop only one hero. Okay, see that loop. Okay, only one hero in the loop. Don't draw more than one hero in a loop. Only one hero. Then what is the directions? Your hero is your directions. The loop, I said loop means current flow. So your direction is your hero. Okay, your hero dotted line is your directions. Your direct dotted line is your direction. That's all. Keep in your mind. What about cut set? Only one hero in the cut. Only one hero in the cut. Who is the hero? Twink. Twinkle, twinkle. I said about that one. So Twink is your hero. Only one hero in the cut. So maximum one twink you can consider multiple number of the links. So you have consider here is a one twink multiple links. Okay, here three. I can't to cut here because three heroes are there. No, then one hero and then I will going to cut. Then one hero I will going to cut. Like okay, then what is my direction? My hero is my direction. My hero is my direction. What hero is saying? Inward direction. All of you go inside. He's saying inward. If the hero is saying outward direction, means all the members go outside. That's all. Very simple. So very simple. You can keep in your mind only one hero. Okay, the hero is a tie, or the hero is maybe twink. And here coming to that instant matrix, then how to write about that inside. So I said that about that one, it's a how many nodes? 1 2 3 4 nodes. First I'm standing here. uh, it's a coming to that one, problem is coming to my mind. If it is a problem is coming to my mind, means I will going to give the -1. If problem is going away, means +1 I will going to give. That's all. If I'm standing here, so 1 2 and what is this one? 1 2 and is this a 6? Okay, 1 2 and 6, three members are the going away, so no problem is going away, so I will going to give the +1 to these members. So remaining is not connected to that one, then I will put it on the 0. So that's all about. Okay, let's we going to solve about that one problem. Okay, so this first they are given the circuit, convert into the graph. How to convert? Like you can convert. Okay, then arrow is there given. Yes, then you can follow the arrow. Okay, then after that no, after that are they given the node terminals name? If not, then you can give A, B, C, D. You can give. Then branch numbers you can give 1 2 3 4 5 6, wherever you can give. Okay, so now it's a node is ready, branch is ready, then write about node versus the branch. So instant matrix is over. Then coming to the tie set matrix, so what you want to redraw the diagrams. So how to redraw the diagrams? So here is a rule is there. What is the rule? The rule is, what is the rule? Join all the nodes. So A B C D, join all the nodes. Okay, don't form the closed circuit. Does it circuit is closed? No. So how to what are the various possibilities? Also you can try to find out. So what are the possibilities? You can use like, I got joined all node. Yes, I got joined it. So don't change the circuit. Yes. So this is the one possibilities. Then here you can do the dotted line. Here you can do the dotted line. Here you can do the dotted line. Or another possibilities? Yes, another possibilities also there. Okay, join all the nodes. Don't form the closed circuits. Yes, these are another possibilities. Join all the nodes. Don't form the closed circuits. Any other possibilities? These are the things. Okay, that's all. So you can take. So I have take about simple. Then remaining is a dotted line. Then I said hero is a dotted line. Only one hero. So in that one hero, you follow the directions. You will go to loop. You can create. Okay. Then write the equations. Okay. So this is about the graph. So that's all about that one. So major things we have covered about that one. And dot connection and coupling coefficients. What is the dot connections? Maybe addition or the subtractions. Okay, if both are the enter on the dotted line means addition. Okay, or both also leave on the dotted line means that is also additions. But one is enter, one is opposite means that is called a subtractions. That is a subtractions. Okay, so this is about the dot rules. Both also enter on the dot line or both also leave on the dotted line. Okay, this is called additions. What additions? Self inductance plus mutual inductance. These two is addition. If it is one is enter on the one coil is enter on the dotted line, another coil leave on the dotted line means subtraction. What subtraction? Self inductance minus the mutual inductance. This is about the dot rule, dot connections. Coupling coefficient, what it is saying? Coupling coefficient means this is a formula. What is that formula? K. That is denoted letter is a K. K is equal to capital M divided by root of L1 into L2. Or this root of L1 and L2 also maximum M you can say. What is the M? M is a mutual inductance divided by maximum value of the mutual inductance. The ratio of the actual mutual inductance divided by maximum value of the mutual inductance. The ratio of the mutual inductance, actual mutual inductance divided by maximum value of the mutual inductance, it is called a coupling coefficient. Okay, so that's all.